This done or not? Here we go. So let's see here. Let's do this on scratch work right here. Let's talk about the probability for number one. What's the probability that Jubin gets it? All right. How'd you get that? A lot of multiplication, huh? All right. Let's take a look. In order for Jubin to get it, all of these things have to happen, correct? So we have to have a right-hand turn, which is a 1/4 probability. Oh, I hate my life. So, in order for Jubin to get it, the bus has to go here, right? So first, it has to take a right-hand turn. There's a 1/4 probability. Then it has to go straight, 3/4 probability. Then it has to take a left-hand turn, 1/4 probability. And then it has to go straight again, right? So that would be, so first 1/4. You guys see how I see what I'm doing? And then 3/4. And you multiply all these? Is that right? Yeah. Why do you multiply them instead of add them? Because they're dependent on one another? Oh. Because like this one here has to happen before this one can happen, right? Okay. 3/4, then 1/4, because we have to take a turn there. Is that right? And then another 3/4. Is that right? So are we good? Yeah. And so that's 9 over. You said 256. Really? 256. Okay. Let's see. Do you guys all, does everybody agree or does anybody disagree? I don't know, Christina, what do you think? You agree. So everybody got that? Yeah? Okay. That's what I got. So, the probability that Jubin gets it? Good. Alright, second one. Let's talk about the probability that America is toast. Oh. Nothing, America. Never mind. We're talking about you, not to you. Mind your own business. Whoa. All right. So, is it, did you guys do this? 1/4 times 3/4 times 1/4 times 1/4? Say again. 1/4 times 3/4 times 1/4 times 1/4. So 1/4 cubed times 3/4. Is that good? So I think the denominator is still 256. Okay, are we good? Are you sure? No questions. 100% sure. Okay, let me see if I agree. Oh, I think I agree. Alright, I agree. Okay, next one. Let's see, next one we got, oh boy. What's the probability that, oh, one of those three happens? So what's the probability that I get it, or America gets it, or Jubin gets it? So what do we not know that we have to know in order to answer that question? So we got to figure out first what's the probability that Mr. Brown is pushing up daisies. So, let's take a look at our map. Is it 1/4 times 3/4 times 3/4? Is that right? Yeah? Jubin, is it 1/4 times 3/4 times 3/4? Okay. 1/4 times 3/4 squared. You sure? Karima, that's good? So what is that? 9 over 64? Right? Okay. So in order to do the probability that because that's me, right? How do I figure this out? Just add them up. So this would be 9 plus 3 plus 36 Would you guys agree with that? Yeah? Where'd I get 36? I get people looking at me like, whoa, what's this magic you're doing? Uh-oh. Yeah, I made this like multiplied by 4 over 4, right? So what is that? 48 out of 256. Okay. Yeah. You can leave it like that. You could simplify it.
How do we know when they don't want us to
Well, probabilities are often okay to leave unsimplified because a lot of times you end up doing other math that would require a common denominator, and a lot of times the denominator is going to be 256 for this kind of problem. Yeah, so probabilities are pretty much the only time that it's okay to leave fractions like this. All right. Hector, do you think it's okay to be one of the three of us, or would you rather be one of the not three of us? Huh?
Be one of the three of us.
Yeah, one of those three is not too bad, because that's a pretty... Well, considering there's not a lot of people that are going to get it. There's one of us, right? Like these three, pretty safe. Who's the least safe?
Yeah.
No, out of this group I meant.
You are.
I'm the least safe. Because, like, this is way smaller than this. Right? Same numerator, much bigger denominator. Right? And which of these is better? America's safer. Huh. Okay. Let's see here. Oh, what about number 4? What's the probability, what was it, that it's not Sophia? 1/4, because it's 3/4 that it is. So it's going to be somebody, right? So 3/4 probability of Sophia, that means there's a 1/4 chance for everybody else. All included. So good? Alright. So you guys understand kind of how these tree diagrams work. They don't always look like this, but, you know, it's still the same way. Alright, I got a couple more questions for you. What's the probability, let's see here. What's the probability that... We've done them all, haven't we? Is there anybody on here we didn't get yet? What's the probability? How about this? How about we do this? What's the probability that either Sophia or Mr. Brown? One of us is going to be pushing up daisies. No, we already got that. Taking is taking a dirt nap. Yeah, these are all euphemisms for being dead. So what do you got?
Google Maps.
Jubin, are we? You got this already? You're there. What's that mean, Jubin? So you have it yet? Because you're highly distracted today. Yeah. Yeah? How many of you guys got that? Okay. All right. Any other questions? Okay, next one. Man, that was fancy. Told you this was going to be fun. All right. Now, let's say you're back in biology. All right. And there's a jar filled with,
Frog eyeball.
how do you spell formaldehyde? I have no idea if that's how you spell it. In fact, my confidence in my spelling of formaldehyde is so low that I'm going to go ahead and put that there.
Watch it be like.
Nah, it's okay.
It won't even give us a
Yeah, let's Siri. Let's see what Siri says. How do you spell formaldehyde? How do you spell formaldehyde?
It says maldehyde, but it's like the name of a person.
Oh boy.
Formaldehyde.
Formaldehyde.
It's like form and then
Oh,
Oh.
formaldehyde. Okay, that's how you spell it then.
and then that A between the D and the H is an E.
Duh. Everybody knows that.
So
What
Formaldehyde's like a, it's what they preserve things in for dissecting or for scientific research. So anyway, there's a jar filled with formaldehyde, and there are 11 eyeballs. In the jar. That is a horrible sentence.
Oh, where did the eyeball come from?
Humans.
Okay.
In fact,
um,
5 of the eyeballs, this is funny, are from boys.
So,
1 got away.
one guy.
Ha! 1 got away. Okay, you're going to choose 2. Okay, you're going to choose 2, but you're going to do them one at a time. So what happens is you pick one, but you do not replace it. You pick one, but you don't replace it. So what we're going to do right here is we're going to make a tree diagram of all of the possibilities. Okay? So we got first choice. And we got second choice. I'll show you how to do this. So what we're going to do is we're going to make a tree diagram of all of the possibilities of how the choices could work. Okay? And we're going to put all the probabilities that are associated with those choices. You ready? So the instructions might say, create a tree diagram. Dang it, I don't know why that pen's not working. Of the 2 picks. So you pick once, you don't put it back. And then you pick again. So we're going to make a tree diagram of how that would work out. Make sense? Yeah? Okay, so we have first choice, we got second choice. So first choice, right? It could be male, or it could be female. How do you tell? How could you?
Just a little marker. They drew on it before they put it.
Oh, they drew on it before they put it in there?
Or they died in
Oh, or it's dyed? Oh. Yeah.
Like me.
But aren't your eyes the window to the soul? So couldn't you look at the eyeball and just tell?
Yeah, you need a body. You need a body to hold your soul.
All right. Hey,
When you die, doesn't your soul die also?
what is the probability of the eyeball being male? What's the probability that the first one's male? 5 out of 11. So this is what you do right here. And what's the probability that it's female? 6 out of 11. Why are there only 5 male eyeballs?
Because guys are stupid.
One of them is Patrick.
Or-
What if it's a woman with a guy?
What if it's Betty White?
Yeah. What if
All right.
And one of the guys
He still has an eye. Just like really.
Okay. Now we have our second choice. So I'm going to just extend this so I got a little more room to write, okay? So in our second choice, it could be male or female. What would be the probability that the second choice is male?
4 out of 10.
How'd you get 4 out of 10? Somebody explain that for me, please.
You didn't replace the eyeball, so I
So you already kept it. There were 5. You already have one of them. It's male. Now there are 10 left total, and 4 of those would be male. So 4 out of 10. And what would be the probability that it would be female, though?
6 out of 10.
6 out of 10.
No.
Yeah.
Yeah, because you didn't choose a
Yeah. Because the first one you took out was male. So that reduced the total from 10 to 11. But since you picked a male, that means there's still 6 females left. Good to go? You see how that? See where that comes from? Like some people got it right away, but some people are kind of confused by it. I don't know. How are we doing with that, Ruby? Yeah? How about Mia? Yeah? Hector, you look real comfortable today. Are you learning today? Yeah? Alright. Okay, what about this one? What's the probability that this one's male? 5 out of 10, because this would be along this branch right here. You already drew an eyeball, right? And it was female, which means there's still five male eyeballs left, right? But since you already took one, the total went from 11 to 10. Went from 11 to 10, but there's still 5 male left. Okay, and what would be the probability that the second pick is female? 5 out of 10? So we're good? That was a very ugly tree diagram. When I did it in my notes, I did it way prettier. Like, I left more room to write. That's a little better. I just left room to write so it'd be neater. Yeah, I should have done it like that. Hey, America, I have a question for you. Are you ready? Good. Why is this female, the second pick, 6/10? Oh, and they have to add up to 1. That's true. Why is this 4/10? Ah, because this means that there was 5 male total and 11, or 5 male and 11 total, right? We chose a male, which meant there were 4 left, and since we took one, there's 10. All right. So, ignoring this, why is this 6/10, America? Ignoring this, why is this 6 out of 10? You don't know? Oh, who do you think knows? You think Kreema knows? Let's see.
Because since you already took one out, then the total is 10, but there's still the 6 of the...
Right. So we took one out. There were 11. That means there's only 10 left, right? And there were 6 female eyeballs to begin with, and there's still 6 there. Does that make sense, America? Oh. Do you see why? America, tell me why this one's 5/10.
Because there were 6 11s and now you took one out, so now it's 10.
Okay.
And then there was 5 in there.
Right, and the first choice was female. Yeah. All right. Hey, Alexis, tell me why this is 5/10.
Because you took one eyeball from the female, so that's 5, and then you took one from the
From the total? Right. Whoop, whoop. Okay. Let's see here. Oh, man, that is the ugliest tree diagram ever. Oh. I thought when I drew it right now I'd be able to do it better, but epic fail. With a unibrow. Okay, here we go. What's the probability? What's the probability that you choose twice without replacement? So you pick one, and you pick another, and they're both male. Anybody got an idea how to do that?
5, 10.
So you would do, say what? Say it again?
5, 11, 10, 4, 10.
Yeah, because that would be this route right here, right? Do you see? So it would be 5 out of 11 times 4 out of 10. So 20 out of 210. Are we good? Oh, hey, look, a squirrel. Well, that is weird. That is so weird. You know why I wrote 210? I think I wrote 210 because I was saying 20 when I was writing it. And so, yeah. And here's what's so weird. When I did that same problem earlier, I didn't fix it right now. I fixed it earlier. I did not look at my answer when I wrote it right now. Oh, my gosh. Wow. All right. You guys tell me. What's the probability that the first one's male, the second one's female? So you do the same way, right? This one is, what's the probability the first one's male? 5 out of 11. Now, given that condition, what's the probability the second one's female?
6 times.
So that's 30 out of 110. Mario, is this easy? Yeah. This part's easy. The part that's not easy, or that gets confusing, is filling out this second part. Yeah. All right. What's the probability that the first one's female? You okay?
Yeah.
You don't look okay.
You're dying.
We're all dying. All right. What's the probability the first one's female, second one's male? 6 over 11 times 5 over 10. Do you see how you just use the chart to fill it out? Like, this isn't the math. The math is writing these things down from the chart. That's the part that you have to do. Because if they get, I mean, that's easy. Like, just figuring that out. Like, anybody knows it's not over 210, it's over 110. Wait, are those the same?
Yeah.
Weird. Okay. What's the probability that they were both female?
11 times 5 times.
Same thing. 6 over 11 times 5 over 10.
Are we sure the first one is right?
Yeah. No.
And they're all in the same color.
All right. My next question for you is, how would this change? Right? So how would this change if the eyeball was replaced?
All of the pieces would stay alone. How would it change? To 121. How would it change if the eyeball was fixed?
How would this
Can you wish English?
How would this change if the eyeball was replaced? So listen right here, because I don't want you guys to get mixed up. Because what happens is you guys get used to just seeing a style of writing, but you don't read the context. And they're totally different situations. So what would be the probability that you picked one, it was male, you put it back, you randomly picked another, and it was also male?
121.
So, because the first one would be 5 over 11, right? And the second one would also be 5 over 11, so, well, 25 over 121. Are we good? What would be the probability that it would be female and male with replacement? So you pick it, it's female, put it back, grab another one, it's male. Set it up, set it up. I want to see, I want to make sure. Are you sure? You sure?
Yeah.
You sure? Is it the same?
I've never been
Wait.
sure about why.
So this is 6 out of 11, and that's 5 out of 11. Okay, so 30 out of 121. Easy. Okay, no problems. So we're doing good. Jubin, no issues so far. All right. How about Mia? No? What's up, Saul?
How would you say this compares to the harder ones that they have?
So far, so good. So far, it's pretty easy. No, this is pretty easy so far.
So like in like the test, would it go up to like more than 2 choices? Like on like 3 or 4?
What do you mean?
You know how you can like pick one and you can pick another one, and you can go like after you can pick another one.
Sure. No, it doesn't usually go too far. All right.
So when it says how would this change, it wants us to do nothing.
All right. Let me see if I can help you guys out with the hard part. We need a situation. We're going to have a tree diagram right here. So let's say we've got our first choice. And we'll go ahead and make it prettier like I did on. Looks like a rocket ship. Hey, what's our experiment? Sophia coughs or Sophia doesn't cough? Mm. Okay, so but over what time period? First period and second period? Okay. Oh yeah. So really that's the best you got? Sophia coughing? We could do better. We need better. How about no, we wore that one out already. Yeah, we need something new, something creative. Yeah.
How about the people that walk by, like how you call them stray dogs?
Uh-huh.
Like during the beginning of the day, during the end of the day.
How many times a freshman passes by?
Yeah.
Oh, that, I don't think has that been done yet?
Stray children in the hallway, huh?
Yes!
Stray children.
Straight children in the hallway.
Yep. All right. So we got yes or no, right? So let's say this is day 1, and this is day 2. Okay? And it's just yes or no. So we got yes, and we got no. Let's say, oh man, I lost my paper with my situation. Let's say that the probability for yes on day 1 is 72%. Okay? And let's say that the probability that it's yes on day 1 and yes on day 2 is 0.35. What's the probability that it's yes on day 2? Given that yes on day 1 and yes both days is 0.35. What's the probability of yes on day 2? Well, Anybody got an idea?
Don't you should do 30.35 divided by 0.72.
Why is that?
Because you do 0.72 times x, which is the probability of
So let's break that apart a little bit. Here's what you've been saying. So he's saying really quickly. He's mentioning that, like, if we were going to figure out this probability right here, what we would do is we would take this times this. Do you agree? Because yeah, like for example, the way we figured out that this was really 20 over 110, not 210, was we multiplied this times that. Right? You follow me? So here, the whole thing is equal to 0.35. So he says we take 0.72 times the thing you don't know equals 0.35. So the thing we don't know is 0.35 divided by 0.72. I got a calculator right here, handy dandy. 0.35 divided by 0.72. 0.49486. Do you guys see how that worked? You have a homework problem that's kind of like that. You have a homework problem that's kind of like that. All right. So we're good? Okay. Your homework today. It's in the blue book. It's 12.2. That's on pages 350 and 351. You can go ahead and get started.